Right now, uh, your most sensitive business data is likely sitting on the exact same physical hard drive as your biggest competitor's data.
Yeah.
And, you are being charged for it by the byte.
It's a wild thing to think about, really.
It totally is. So today we're doing a deep dive to kind of tear down the illusion of the cloud. I mean, we treat it like this magical, weightless ether, right?
Right, where our photos and corporate databases just float seamlessly.
Exactly. But there is no magic. There are only highly physical, heavily monetized, and honestly, brilliantly engineered data centers.
Yeah, concrete and steel.
Exactly. And whether you're making major IT decisions for a massive company or you just want to understand the invisible infrastructure running your digital life, figuring out the true mechanics of the cloud is an absolute necessity for you.
It changes everything once you stop looking at it as an abstract concept. I mean, when you actually understand who owns the hardware, how the billing traps work, and where the legal liabilities lie, you stop being a passive consumer.
You actually know what's going on.
Right?
Yeah.
You gain financial control and security awareness. In a world where every single app and service is migrating off premises, knowing how your data is handled, well, it gives you your power back.
It really does. So to get us there, we are pulling apart an incredibly detailed set of IT certification transcripts from Professor Messer.
The CompTIA materials.
Yeah, specifically the CompTIA A plus 220-1201 course materials. This deep dive is entirely focused on cloud characteristics and deployment models.
A great place to start.
Yeah. Our mission here is to cut through the buzzwords. We're going to map out the real estate, dissect the pricing models that just, catch companies totally off guard.
Oh, they definitely do.
And we'll establish exactly where a cloud provider's responsibility ends and yours begins.
I think the best place to start is with the physical reality. Before we even get to the software or the economics, we have to look at the blinking lights and spinning hard drives.
The actual metal.
Exactly. The foundation of all cloud computing is the deployment model, which really comes down to one basic question: who owns the facility?
Right. And the most straightforward answer to that is what the material calls a private cloud, or an internal cloud.
Yeah, that's the traditional heavy-duty approach.
Right. An organization literally builds its own data center.
Yeah.
They buy the servers, the server racks, the cooling systems.
A massive backup generators?
Oh, yeah, those too.
Yeah.
And their own internal IT team handles the physical installation and all the ongoing maintenance.
And the barrier to entry there is an absolutely massive upfront capital expenditure.
For huge amounts of cash.
Unbelievable amounts. You are pouring millions of dollars into concrete, copper, and silicon before a single byte of data is ever processed.
Wow.
But, there is a massive strategic upside. Once that private internal cloud is up and running, you own it outright.
No landlord.
Exactly. No landlord. There are no metered pay-as-you-go costs. If you want to run those servers at 100% capacity, 24 hours a day, 7 days a week, your only ongoing expense is the electricity and your IT staff.
Right, because all the hardware is dedicated entirely to your organization. Okay, let's unpack this. It's basically like real estate, or like building a bespoke manufacturing plant. You take a huge financial hit to construct it, but once it's built, you aren't paying a landlord a premium for every widget you produce off the assembly line.
That's a perfect analogy.
But obviously, most companies today don't want to be in the business of building manufacturing plants. They just want the widgets.
Right. They just want the end product.
Which brings us to the public cloud, or the external cloud.
So in a public cloud model, a massive provider, think Amazon, Microsoft, or Rackspace, they take on that initial capital expenditure.
They build the massive factories.
They build the data centers. They buy the hundreds of thousands of servers. You, as the customer, well, you don't unbox a single piece of hardware.
You just log in.
Yeah, you just connect to their infrastructure over the public internet and start working.
And you rent the space, like renting a hotel room instead of buying the whole mansion. But companies don't always have to make a binary choice between building their own plant or renting space in a public one. Right. The materials detail something called a hybrid cloud model.
Yes, the hybrid approach is incredibly common.
Because a company might keep their highly sensitive, proprietary databases locked down in their own private cloud, but then use the public cloud to host their customer-facing website.
Yeah, you deploy the asset where it makes the most sense from a security and financial perspective. And there's also a variation called a community cloud.
Oh, right, the co-op model.
Basically, yeah. This happens when multiple smaller organizations, perhaps hospitals in the same region or universities sharing research resources, decide to partner up.
They team up to share the burden.
Right. They pool their budgets to build a shared cloud infrastructure. It provides the strict control and dedicated resources of a private setup, but they share the immense upfront costs.
Okay, so if a private cloud is building your own factory and a community cloud is a co-op, let's look closer at that public cloud model. If you are just renting space on Amazon or Microsoft servers and you aren't paying that massive upfront capital cost, how does the provider actually make their money?
Oh, they make their money.
Right. I mean, how do the economics work when you are just logging in over the internet?
Well, the economics are where the cloud gets incredibly precise and potentially very dangerous for a business. The billing model depends entirely on the type of user you are.
Okay.
The materials draw a very clear distinction. If you are a consumer, say, you're paying for cloud storage for your smartphone backups, your billing is generally non-metered.
Right. A flat monthly rate. I pay a few dollars a month and I get like a 2 GB block of storage. Whether I upload 5 photos this month or 500, my credit card gets charged the exact same amount.
As long as you don't cross that 2 GB threshold, yes.
Right.
But if you are a business enterprise running applications in the public cloud, those flat rates disappear. The enterprise model runs on metered utilization.
Everything is tracked.
Everything. You pay for exactly what you use, calculated down to the byte, the second, and the specific CPU cycle.
Wow.
And to really understand how metered billing impacts a budget, we have to talk about traffic direction. The cloud providers tracked data moving in and data moving out very differently.
Yeah, the terminology used here is ingress and egress traffic.
Exactly.
So ingress is data being uploaded into the cloud, like when a company transfers its massive customer database up to the provider's servers. Egress is the exact opposite. That is data leaving the cloud, flowing out to the users.
Right.
So when a customer streams a video from your app or downloads a PDF, that is egress traffic. And what really stands out in the material is that providers often charge vastly different rates for these two directions.
They absolutely do, and it is a deliberate business strategy.
Oh, I bet.
Providers want your data in their ecosystem. They want to be sticky. So ingress traffic bringing data in is often very cheap, or sometimes entirely free.
They roll out their carpet for you to arrive.
Exactly. But egress traffic sending that data out across the internet to your users is metered and taxed heavily. The more popular your application is, the more egress traffic it generates, and the higher your monthly invoice climbs.
Which introduces a massive variable.
Mm.
Here's where it gets really interesting. If billing is tied directly to usage, how do you handle unpredictable traffic?
That's the million-dollar question.
Right, because in the old private data center model, if your business got a sudden spike in popularity, say, a viral marketing campaign, you had a physical problem.
Your servers would hit maximum capacity and your website would just crash.
Just totally go offline.
Yeah.
You'd have to physically order more servers, wait weeks for delivery, unbox them, rack them, and configure them just to handle the new load.
And by the time the new servers were installed, well, the viral moment was over. You missed it. The public cloud eliminates that physical bottleneck through a characteristic called elasticity. Because the provider has a massive pool of resources just sitting there, you don't have to wait for hardware.
It's just ready to go.
Yeah. You can configure your application to scale up instantly. When traffic spikes, the cloud automatically pushes a button, basically spinning up new virtual servers and allocating more network bandwidth in real time to absorb the hit.
And when the traffic dies down, it automatically scales back down, releasing those resources. It's brilliant.
It is brilliant technically, yes.
But let's look at the financial reality of that. Think of metered cloud elasticity, like an Uber surge pricing model for your website.
Oh, that's a scary thought.
Right. If 10,000 people suddenly show up, elasticity automatically sends 10,000 cars to pick up the traffic so your site doesn't crash. But because you are paying for the egress traffic, the ride for every single one of those users, your bill for that afternoon, could exceed your entire annual IT budget.
Yep.
You survive the traffic spike, but you might bankrupt the company paying the invoice.
That is exactly the phenomenon known as cloud shock. And it is why the technical ability to scale must be paired with extreme financial oversight.
You can't just set it and forget it.
Definitely not. Setting up an elastic cloud environment without implementing strict monetary caps or alert thresholds is a recipe for disaster. The elasticity ensures your application stays online, sure, but it has no inherent concept of your bank account balance.
Doesn't care if you can afford it.
Exactly. Managing the cloud isn't just about managing technology anymore. It is about managing an incredibly volatile, minute-by-minute
You egress bill because you went viral.
A physical server would have just crashed under that traffic.
Yeah.
The only reason you even survived to get that bill is because of how the cloud handles capacity behind the scenes.
Right.
If businesses all over the world are constantly expanding and contracting on a whim, surging up and down, how does the provider afford to keep enough empty surge cars waiting? I mean, they can't just have warehouses full of millions of dollars of idle servers waiting for your specific company to go viral, can they?
They don't. The entire economic viability of the public cloud relies on a concept called multi-tenancy.
Multi-tenancy.
Yeah. To make the math work, providers need every piece of hardware to be utilized as much as possible all the time. So they pool the resources. Multi-tenancy means that multiple tenants, different customers, different companies are all operating simultaneously on the exact same physical infrastructure.
Wait. This brings me back to the hook we opened with. You are telling me that my company's financial databases, our proprietary algorithms, might be processing on the exact same physical CPU and saving to the exact same physical hard drive as our biggest competitor.
Yep, that is exactly what I'm telling you.
But if we are all crammed into the same physical box to save the provider money, how is that not the biggest security vulnerability on the planet?
I mean, it sounds like a nightmare if you picture a standard laptop hard drive where all the files are just sitting in folders next to each other.
Yeah, that's exactly what I was picturing.
Right, but this is where the mechanism of virtualization comes into play. The providers use a highly specialized layer of software called a hypervisor.
A hypervisor.
The hypervisor acts like an omnipotent traffic cop sitting directly on top of the physical hardware.
So it's an intermediary between the physical metal and the customers.
Precisely. It creates virtual machines, basically, sandboxed, isolated environments for each tenant.
Okay.
The hypervisor tricks your competitor's data into thinking it has its own dedicated physical drive and its own dedicated processor. It completely isolates the memory and storage spaces so that the data streams physically cannot cross paths.
Wow, so they never touch.
Never. It is an invisible, ironclad wall enforced at the architectural level. One customer cannot see, access, or even detect the presence of another customer on that same server.
Okay, that virtualization layer explains so much. And it's not just about security, right? It fundamentally changes how reliable the systems are.
Absolutely.
The materials highlight availability as a core cloud characteristic. In a private data center, if the physical hard drive running your database catches fire, your system is down until a human being walks in and replaces the drive.
Right, you're at the mercy of physical hardware. But in a multi-tenant cloud environment, your application isn't tied to a specific piece of physical metal. It exists as a virtual instance managed by that hypervisor.
So it's kind of floating above the metal.
Essentially, yes. If a physical drive array starts failing or a network switch drops, the hypervisor detects the hardware degradation and instantly migrates your virtual machine to a completely different, healthy physical server within the data center.
Oh, wow.
The hardware dies, but your application doesn't even skip a beat.
It just slides over to functional equipment seamlessly. And that is amazing. And it scales even larger than a single building, doesn't it? The material specifically points out file synchronization. To ensure true availability, providers don't just rely on redundancies within one data center. They automatically synchronize your data across multiple geographical regions.
Yeah, that global synchronization is the ultimate safety net. If a catastrophic event, a hurricane, a massive power grid failure, a severed fiber optic trunk takes an entire data center offline in Virginia, well, the cloud provider simply routes the traffic to the synchronized backup data center in Ohio or Europe.
And the end user never knows the difference.
Exactly. It's completely transparent to them.
But, okay, with all these moving parts, hypervisors, sandboxing competitors on the same chips, automated elasticity spinning up resources in seconds, and global synchronization duplicating files across continents, we're run into a massive operational question.
Who is responsible?
Right. When something inevitably breaks or when a security breach does happen, who gets fired? Where does the provider's liability end and where does your liability begin?
That is the defining question of modern IT, and it is answered by what the materials call the cloud responsibility matrix.
The matrix?
Yeah. You are entering into a shared responsibility model, and the line in the sand depends entirely on which of the three main implementation models you choose: IA, Pay, or SaaS.
Okay, let's start with the one that gives the customer the most control but also the most liability, IaaS, which stands for Infrastructure as a Service. And the text notes you might also hear this referred to as Hardware as a Service, or HaaS.
Infrastructure as a service is exactly what it sounds like. You are renting the raw capabilities of the data center.
Just the basics.
The provider supplies the physical building, the power, the cooling, the network connectivity, and the bare metal servers. They guarantee the hardware will turn on.
Right.
Everything above that physical layer is entirely your problem.
The course materials use Professor Messer's own website as a prime example of IS. He rents the server time from a cloud provider. They make sure the physical machine is running.
Yeah.
But he has to install the operating system himself.
All of it.
If there is a critical security vulnerability in Linux or Windows, the cloud provider isn't going to patch it for him. He has to update the OS, install the web server software, write the code, and secure the databases.
He's on the hook.
Totally on the hook. If his site gets hacked because he forgot to install a security patch, he can't blame the cloud provider. He holds all the responsibility for the software and the data.
It is the maximum amount of management overhead, for sure, but it grants you absolute granular control over your environment.
You're the boss.
Exactly. Now, on the polar opposite end of that matrix is SaaS, or software as a service. This is the model that really dominates our daily lives.
Everyone knows SaaS. It's Google Mail, Microsoft 365, Dropbox. You just open a web browser, type in your password, and start working. You don't manage the hardware, you don't install an operating system, and you certainly don't write the application code.
Nope, none of it. But what most people, and honestly even some IT directors, forget is the underlying trade-off of SaaS.
Right, the catch.
You offload the entire technical headache. You don't need a team of developers or system administrators. The provider handles the physical servers, the hypervisors, the OS patches, the application updates, and the data synchronization.
That sounds great.
It is, but in exchange for that convenience, you sign away ultimate control. You cannot customize the underlying infrastructure to suit your specific security needs. You operate entirely within the parameters the provider dictates.
Which brings us to the middle ground. The third model the materials cover is PAL, Platform as a Service. It sits right between the raw metal of IS and the lockdown finality of SaaS.
Platform as a Service is an incredibly powerful hybrid. In this model, the provider handles the physical data center and the underlying operating system platform.
Oh.
You don't have to worry about updating Windows or configuring network firewalls, but they don't give you a finished application like an email client.
So what do you get?
Instead, they hand you a development platform and your team writes the actual application that runs on top of it.
Okay, let's visualize this. If infrastructure as a service IS is a provider handing you a raw plot of land and a pile of lumber where you have to build the entire house from scratch,
Good analogy.
then software as a service IS is moving into a fully furnished luxury apartment.
Yeah.
You just bring your keys, but you aren't allowed to knock down any walls.
Right.
Platform as a service PIS is entirely different. PIS is like being handed a massive box of high-tech Lego building blocks.
I think that captures the dynamic really well. The provider manufactures the high-quality plastic, they build the foundation plate, they guarantee that all the pieces will click together flawlessly.
Right. You don't have to worry about the chemical composition of the plastic or whether the pieces will fit. The platform is rock solid. But, and this is the crucial part, it is entirely up to you to figure out how those blocks are arranged. You have to build the spaceship yourself.
And we have to add the liability nuance to those Legos. The provider guarantees the plastic won't melt. But if you build a spaceship with a fundamentally flawed design, if there's a gaping hole in your security architecture, the provider will not step in to fix it.
That's your mess.
Yep. If your data leaks because you arranged the blocks poorly, that is on you. The sources point to Salesforce.com as a prime example of this.
Right. Salesforce.
Most people use Salesforce as a SaaS product. They log into the pre-built CRM. But Salesforce also provides an extensive PaaS environment where developers can snap together modules to build completely custom proprietary applications for their business.
Wow, okay. So it's all about finding the exact intersection of capability and liability that your business needs.
Yeah.
That responsibility matrix isn't just technical documentation. It's a legal line in the sand.
It absolutely is.
If you build an internal private cloud, you carry 100% of the burden. If you use IaaS, the provider covers the metal, you cover the OS in the app. PaaS, they handle the platform, you write the code. SaaS is they do all the heavy lifting, and you just consume the service.
When you lay it out like that, the illusion of the cloud completely evaporates, doesn't it?
It really does.
It isn't magic. It is a highly specific matrix of deployment models dictated by rigid economic mechanics. You're constantly balancing the immense power of elasticity against the financial dangers of metered ingress and egress billing.
It really shifts your perspective. You aren't just blindly clicking accept terms and conditions anymore.
No, you can't afford to.
Right. Because once you understand the physical architecture, the hypervisor sandboxing your data, and the strict boundaries of responsibility, you realize every interaction with the cloud is a calculated transaction.
That is the ultimate takeaway here.
Hmm.
Whether you are an entrepreneur trying to decide if you need to buy physical servers for a startup, an IT director auditing a massive public cloud invoice, or just an everyday user wondering how your personal files are stored, this knowledge is leverage.
It's control.
Exactly. Knowing who holds the keys to the hardware and exactly who is responsible for the software puts you in a position to make informed strategic decisions, rather than just trusting the buzzwords.
The cloud is finally grounded. It's just physical machines, brilliant software layers, and carefully structured contracts.
It is. But I do want to leave you with one final thought based on a mechanism we discussed earlier. We talked about file synchronization, right?
The way public cloud providers automatically duplicate your data across multiple geographical data centers.
Yes, to ensure total availability. The redundancies that keep everything online when a server fails.
Right.
To maintain that illusion of being everywhere all at once, your data is constantly on the move, which means your personal documents, your private photos, your entire digital footprint isn't sitting on one specific hard drive in one specific town.
Okay.
It is being silently duplicated, fragmented, and synchronized across server farms spanning multiple continents 24 hours a day.
Wow.
It solves the technical problem of availability, sure, but it begs a rather profound question. If the cloud demands that your information is everywhere all at once, where does your digital identity actually reside right now?